topic review for topic number 2. Now, the first question on here is the essential question as to what this chapter is really all about. What properties are specific to parallel lines and perpendicular lines? Well, with parallel lines, we had a lot of properties. Pretty much everything in this chapter that dealt with any of the theorems, any of the postulates, pretty much almost all related back to either parallel lines or perpendicular lines. So if we had two parallel lines cut by a transversal, then we had certain angles that were congruent and supplementary. We had different angle relationships such as alternate interior angles, alternate exterior angles, same side interior angles, same side exterior angles, linear pair. Let's see, there's one more I think I'm forgetting. But again, lots of different angles. We also had some theorems that related the two together. For example, if we have two lines that are perpendicular to the same line, then they must be parallel. That was one of our theorems. Whenever we have perpendicular lines, we know that we have opposite reciprocal slopes, or in other words, their slopes are going to multiply and give us -1. For parallel lines, we know that slopes are going to be equal, and we know that there's a lot of different properties there. So just keep in mind, and pretty much everything that we've done in this chapter had to do with one of those two things. If you want to take a look at down here, this is an example of another thing that we could talk about in terms of parallel lines. Again, pretty much everything on this paper deals with parallel lines in some way, shape, or form. Now, for the vocab, some of the ways that this section is phrased is a little bit different than the actual definitions that we had. So again, you have to read them carefully and make sure you understand which one of these words applies to this situation. So on the first one, angles that are outside the space between parallel lines and that lie on the same side of a transversal. So again, you might want to draw a slight picture just so you can get an idea of what this is talking about. So again, we have parallel lines cut by transversal, and it's saying the angles that are outside the space between parallel lines, so on the exterior, and that lie on the same side of the transversal. So for example, this angle and this angle, they're outside the parallel lines, but they're on the same side of the transversal. This would be same side exterior angles. Same side exterior angles. On number 3, a blank intersects coplanar lines at distinct points. Well, that'd be a transversal. Again, if I go back to the figure that I drew on number 2 there, this line is what we call transversal. A transversal is any line that's intersecting more than one line at distinct points. So it can't be the same point, it has to be two different points. So again, transversal. On number 4, two angles inside a triangle that correspond to non-adjacent exterior angles are the remote interior angles. Remote interior angles. And if we were to draw a picture of this, so for number 4, so it looks like this. So this angle here, this angle there, compared to an exterior angle. So this one, this is the adjacent interior angle. These two are the remote interior angles. Remote meaning far away. On number 5, blank lie on the same side of a transversal of parallel lines and are in corresponding positions relative to parallel lines. So this would be corresponding angles. So it kind of gives it away because it says in corresponding positions, but corresponding angles is our missing word. Now, on number 6, Angles between parallel lines that are non-adjacent and lie on opposite sides of a transversal are alternate interior angles. So again, just to show a brief picture that would describe this. And between parallel lines, there are non-adjacent, so can't be next to each other, and lay on opposite sides of the transversal. So for example, this one and this one, they're on alternate sides of the transversal. They're not adjacent, they're not next to each other, and they're on opposite sides of that transversal. So between the lines, opposite sides of that transversal, again, non-adjacent. So alternate interior angles. And finally, angles between parallel lines that are on the same side of a transversal. That would be same side interior angles. So again, if I want to draw another picture to help describe this. Angles between the parallel lines, they're on the same side of the transversal. So like, for example, this one and this one. And for a lot of these properties, or for a lot of these names, we also have a property that goes with them as to how they relate. So a lot of them are going to be either congruent or supplementary. But again, this last one was same side interior angles. So now go down here to the first section. Actually, let me mention one other thing up here. A lot of these things said parallel lines. Know that, again, in order to have same side exterior, corresponding alternate interior, same side interior, you don't have to have parallel lines. So based on the description that we had here, yes, it didn't matter if they were parallel or not. They used the word parallel in there. We can name these different parts, but they do not have to only be for parallel lines. When we first named these things, the very first diagram that I gave you guys, I told you to make sure that you didn't show them as parallel so that you could compare what the names were, not what the properties are. When they're parallel, you have extra properties saying that they're either congruent or supplementary. And that's what this next figure down here is. So again, when two parallel lines intersect a transversal, the angle pairs that are formed have special relationships. The angle pairs are either congruent or supplementary. So on this diagram, all the acute angles are going to be congruent. All the obtuse angles are going to be congruent. Any combination of one acute and one obtuse would be supplementary. So they wanted to know which angles are supplementary to 3. So all the acute angles would be supplementary to angle 3. So 1, 4, 5, and 8. Those are the answers. Now, over here, they give us a figure, and they tell us, suppose that these two are parallel. So they're telling us we have parallel lines. What's the measure of each angle? So we know that angle 2, they gave us is 138. Well, if this is 138, so I'm going to do this problem in red. Angle 1, right next to it, these two are a linear pair. They have to add up to 180. So 180 minus 138 is going to give us 42. So that's 42 degrees. Number 3. All right, so here's angle 3. You could say either, hey, we have a linear pair, so again, subtract from 180, or angle 1 and angle 3 are vertical, so this would also be 42. Angle 4. Now, 2 and 4, they're in alternate interior angle positions, so they have to be congruent. So that's going to be 138. If measure angle 1 is equal to 3x minus 3, and measure angle 5 is equal to 7x plus 23, what is the value of x? For what value of x is L and M parallel? So now they rephrase this a little bit, but the essential idea is angle 1 and angle 5, since they are same side exterior angles, they have to be supplementary in order for these two lines to be parallel. So using that fact, we know that these two have to add up to 180. Again, that's what it means to be supplementary. So combine your like terms. 3x and 7x gives us 10x. Negative 3 and positive 23 gives us positive 20. And again, it is equal to 180, because again, the two that we're talking about are same side exterior angles, which have to add up to 180. They're supplementary. Bring the 20 across by subtracting it. So we got 10x equals 160. Divide by 10. X is 16. So that would be our answer for number 9. Number 10. The transversal that intersects two parallel lines forms corresponding angles with measures of, and they give us two equations. Since they told us that we have corresponding angles and parallel lines, corresponding angles when you have parallel lines are congruent. So we're going to set these two equations equal to one another. 3x minus 7 equals 2x plus 12. For the test, you'll have some questions that you don't have to do algebra for, like on these first few. But then you also have problems where you have to do algebra. And when you do algebra, you got to know how to set the equation. So for any of these where you have the diagram with parallel lines, remember, you're either adding the two up and saying them equal to 180 because they're supplementary, or if you have two congruent angles, then you should be saying their measures equal to each other and solving. So in this case, again, they should be equal to each other, so now we need to solve. Bring the 2x over by subtracting it, you end up with just x. On the other side, we still have 12, and we got to get the 7 across. So add 7, so x is equal to 19. Now, that's not the final answer. They asked what is the measure of each angle. Well, these two angles are the same. It doesn't matter which one you plug into. Just take the 19, plug it into one of them. So measure of angle 2 equals 2 times 19 plus 12. 2 times 19 is 38. 38 plus 12 is 50. So, again, now that we know one of the angles, well, again, since they're congruent, measure of angle 1 also has to be 50. And those are, again, degrees. So they're both 50 degrees. The next part was dealing with triangles. There are two main theorems that dealt with triangles, and that was the triangle angle sum theorem, which says that all the angles of a triangle add up to 180, whereas we also had exterior angle theorem. The sum of the exterior angle of a triangle is equal to the sum of the two remote interior angles, meaning the two that, again, are far away from whichever exterior angle we're talking about, and on the inside of the triangle. So remote interior. Now, number 11. This one's just simply, we have a triangle, we have three angles, they all have to add up to 180. So you can do it a couple different ways. I like to show my work as an equation. So I'm going to have 50 plus 74 plus x equals 180. Add these two up, you get 124 plus x equals 180. Subtract off the 124, x is equal to 56 degrees. On number 12, now we have an exterior angle. Again, the exterior angle is equal to the sum of the two remote interior angles. Well, this angle is next to it, so it's adjacent. That doesn't work. These two are remote. They're far away from the original angle. So add these two together, and you should get x. So x equals 32 plus 63. X is 135. On number 13, again, trying to find x, we have an exterior angle. We have one of the two remote. X is the other remote exterior angle. So set up an equation. 152 equals 103 plus x. How do we get x by itself? Subtract off the 103, which leaves us with 49 degrees for x. On number 14, we have an exterior angle. It has to equal the sum of these two. So 66 equals x plus 40. Well, subtract off the 40 from both sides, you get 26 equals x. And again, that's it. On number 15, make sense and persevere. During a storm, a tree is blown against the building so that it forms a triangle with remote interior angles of 90 and 52. What's the measure of the corresponding exterior angle formed by the leaning tree? So I like drawing a little diagram. So here's my building. This is going to be my fallen tree. If you want to add some leaves to it, fine, whatever. But it's making a triangle. I have one angle is 90, another angle is 52. I need to know what the measure of the exterior angle is. So going this way. So we have these two are remote interior angles. We don't actually have to do anything else with the triangle except for add those two together. So whether you drew the picture or not, you should be able to add 52 and 90. So 52 plus 90 is going to give us 142. The last section. Now we're dealing with graphing parallel and perpendicular lines on a coordinate plane. Now the example they show over here, that's fine, but most of these questions don't say how they want you to write your equation. So if you choose to write slope-intercept form, that's fine, and that's what the book did here. Or you can use point-slope form. So now, this is slope-intercept form, this is point-slope form. I think it's easiest just to plug into point-slope form. If you have a point and a slope, plug into this, and you have your equation. If you really want to change it to slope-intercept form, you can then take whatever you plugged in here and solve for y. So, on number 16, the first one is just asking, are they parallel? So, if I look at P and Q, this is P. Pick 2 points I can clearly tell it's going through. So, my slope for this one is up 2 over 1. For Q, you can pick 2 points. Here we're going up 3 and over 1. So 3 over 1. They are not the same. Therefore, they're not parallel. Not parallel. Now, on 17, are the lines perpendicular? So now we're looking at these two lines. So again, pick out points that you can clearly tell it goes through. Like this one and this one. That's up 1 and over 3. For the second one, so that was for W, T, coming down this way. Pick another point that you can clearly see it goes through. Right there. We're going down 5 units. And now we have 3. So again, looking at our slope here, this was 5 and 3. And it was going down and then over. So negative 5/3. These two, are they perpendicular? No, they'd have to be opposite reciprocals. So that does not work. So no, not opposite reciprocals. On 18, why is the vertical line excluded? Very simply, vertical lines have an undefined slope. Now, on number 19, it says, in structure, write an equation for each line that passes through the point and is parallel or perpendicular to the line. Again, point slope form, what I wrote out over here, that's what I recommend doing. You just have to plug in for those 3 values. So the y1, the x, oops, that should be x1, 2, and the slope. So we have x1 and y1. Looking at this equation, we can identify our slope, and that's for the one that's going to be parallel to it. So that's our parallel slope. Our perpendicular slope is going to be the opposite reciprocal of this. This point goes in for both of them. So first, if I do parallel, we'd have 7, sorry, not 7, y minus 7, because again, that's our y1, equals our slope, negative 3, times x minus, well, if I started off with 7 as my point there, again, 2 would be the x value. So now, this is our equation. It's in this format, point-slope form. We don't have to change it to slope-intercept. If you want to, that's fine. But again, this is an acceptable answer. I'm not asking you to change anything else. Now, if you were to actually change this to slope-intercept, you'd first have to distribute the negative 3. So you'd have a couple of steps. Negative 3x plus 6. Bring the 7 over by adding it. Y equals negative 3y plus 13. So again, that would also be acceptable. For the perpendicular line, same point. The only thing that's changing is the slope. The slope for perpendicular is opposite reciprocal. So y minus 7 equals positive 1/3 x minus 2. So again, that is a good answer, and you can leave it like that. However, we do have this fraction here. So if we want to get rid of the fraction, I would first say go ahead and distribute it. 1/3 x minus 2/3. Get rid of the fraction by multiplying everything by 3. 3y minus 21 equals x minus 2. Bring the 21 across. You'd have 3y equals, sorry, yeah. So got 21 across, so 3y equals x plus 19. Divide off the 3, and you'd have y equals 1/3 x plus 19 over 3. Again, that would also work as an answer, but that's a whole lot more work. If you just know point-slope form, it's just a matter of plugging it in. Alright, that was the review. I will also make videos for some of the stuff from Friday. So again, that is the entire review though. Oh, before I stop the recording, I should also mention proofs. Again, there were no proofs on this. There are 2 proofs on the test. So there will be a flowchart. There will be a 2-column proof. But again, it's only 2 proofs. You'll also see some material back from the other tests, the first 2 tests that we have had now. We're going to bring some of those topics back. We're just going to have 2 of them on there this time. So again, not as much as the last one.